Okay, folks, welcome back. And we are now going to tackle the sheet that has the figures on it on one side that have dimensions on them. And we're going to determine the areas of each of these figures just to get a little bit of practice. Then we are going to work on the other side of the sheet, or the second page of the sheet, with the information, working with the formulas in a general sense with just letters and no actual amounts of lengths or heights given. So here we go. Okay, you can refer to the first sheet, hopefully that you kind of filled in as we went through this, where you put the formulas down for the various figures. Okay, I will probably send you a list of formulas and figures that go with them so that you can use that to refer to as you do your work. If I have not provided you with that, then you can use all of this information from the sheet we're going to work on now, plus its back. So here we go. You recognize the first figure in the upper left-hand corner as being a triangle. So we're going to determine the area of the triangle. Remember, you always write the formula first. A equals 1/2 BH. The base, of course, is 14. Its height is 5. So you simply go A equals 1/2 times 14 times 5. I could cancel the 2 with the 14 in my head and just do 7 times 5, which is 35. So the area of this figure is 35, and it would be square units. We don't have any units written on these figures. If they were centimeters, it'd be square centimeters, centimeters to the second. But since we don't have any of those labels on there, we'll just use units. If there were feet, if it were in feet, it would have been 35 feet squared, or square feet. Okay, let's go down to the problem beneath that. It's another triangle, right? And of course, this triangle is a right triangle. So notice its base and its height, its base down here, its height up here are exactly the same, because this is an isosceles right triangle. Two sides are equal in length, and they happen to be the legs of the right triangle, and the hypotenuse is the third side. But to get its area, I will simply do what? I will simply write the formula again. A equals 1/2 BH. Since the base and height are both 12, I will do 1/2 of 12 times 12, or the area of this figure, half of 12 is 6, 6 times 12 is 72. Or if you had multiplied 12 times 12, you would have gotten 144, and then taken a half of it, you would also still again get 72. So there is the answer for this particular question. 72 square units is the area of that triangle. All right, let's go back up here. And this, of course, is a trapezoid. And for this trapezoid, I'm going to determine its area. And if you recall, the area formula for a trapezoid is A equals 1/2 its height multiplied by the sum of its bases, which we usually call B1 and B2. This down here would be B1. This would be B2 up here, and your height, of course, is right here. So I would simply do A equals 1/2 times the height, 12, and I will multiply that by the sum of the bases, which is 15 and 19. And I can do 15 plus 19 ahead of time because it's in parentheses, so I'll make that 34. Here's 12. Here's the 1/2. So to get the area, I can maybe take half of 12, which is 6, and I will do 6 times 34, which I will do on my calculator here. 6 times 34 gives me the answer of 204. So the answer for this trapezoid is 204 units squared. Any questions? I hope not. That's pretty straightforward and simple. You did these from 6th grade on and into high school, so I'm sure this review is helping you bring these back to mind. All right, now you'll notice this figure down here is a little different. It is a trapezoid, all right? However, one of its sides, one of its non-parallel sides happens to be the height. You can see that it's perpendicular. The side, which is 10, is perpendicular to the bottom, so it's got to be perpendicular to the top as well. So to obtain the area of this, it'll still be A equals 1/2 the height multiplied by the sum of the bases again. So it will be 1/2 the height, which is 10, the bases added together, 19 and 13. 19 and 13, of course, is 32. And if I do half of 32, I get 16. I can do a half of either one of the sums here, or either one of the numbers here. So this was 32. So I'm going to do half of 32, which is 16. And 16 times 10 makes 160 square units of area. So pretty simple process. I just want you to get used to this so you can see what I'm going to show you in a very short period of time from now in a video that one of the professors is going to do for you. All right, now what I'd like to do is I would like to go to the next sheet, and I would like for you to go through it with me and write down the various formulas for these figures that would work just using letters. So I don't have them as B's and H's. I have them as different letters, but what would I multiply these letters out by in order to get the area of the figures? Well, notice the first figure is a triangle, okay? Its formula for its area is 1/2 BH, right? Well, the base of this figure is W, right? So I would do 1/2 times W, right, times the height, which in this case would be M. So the answer to this would be 1/2 WM. Could it have been 1/2 MW? Yes, it could have. I could have reversed the M and W. I would still get the same answer because multiplication is commutative. I can reverse their order of things I'm multiplying, but we'll just keep that in mind for later. Okay, let's do the second triangle down here, which again is an isosceles right triangle. Its height and its base are exactly the same. They are both U. How could I write this out as an area problem? Well, I would do 1/2 base times height, and I would do 1/2. The base is U, and the height is U. Therefore, my area of this figure would be 1/2 of U times U, which is the same thing as U squared. So I could express the area of this triangle as 1/2 U squared. All right, let's return and go back up to the top of the sheet again. And let's look at this particular figure. This is a trapezoid, so it's a little bit more complicated, but it is 1/2 for its area times the height multiplied by the sum of the bases. So for the area, I will do 1/2 the height, which is M, and I have to get the sum of the bases, which would be K plus X. And I really can't simplify that any more than that. So that would represent the area of that trapezoid. Okay? Now, I've tried to mess you up a little bit on the next trapezoid. And what I have done is I have split the height into two pieces, C and E. Well, how would I represent the area of this figure using letters? Well, I will write the formula 1/2 height, base 1 plus base 2. I will write area equals 1/2. The height now is in two pieces, C and E. So I'd have to add those together, wouldn't I? So I'm going to write C plus E. So that would make up the height. And then my two bases would be N plus V. So that formula in letters would represent how to get the area of that particular trapezoid. Now I'd like you to take a look at this very strange figure. And notice what it says up at the top of the sheet. There is an axiom of mathematics that says the whole of something has to be equal to the sum of its parts. Now you notice I have divided this figure into several parts. And I'm going to call these parts A1, A2, A3, A4, and A5. There are 5 different pieces here that have areas. If I wanted the area of this figure, and if I knew the area of those 5 pieces, couldn't I just add them together, the areas of the 5 pieces, and wouldn't they give me the area of the entire figure? Well, yes, they would. So in other words, I could write a simple formula up here that the area of the big figure has got to be equal to the area of part 1, the area of part 2 of the figure, plus the area of the third part of the figure, plus the area of the fourth part of the figure, plus the area of the fifth part of the figure. And I want you to notice, if I go down here, here's the same trapezoid, okay? If I turn this trapezoid on so that I can move it, I'm going to move it up. And I want you to notice that that trapezoid is exactly the same size as the one we had in pieces. So the answer to these two would have to be exactly the same, because I have the parts and the whole has to be equal to the sum of the parts. Therefore, that would give us a correct answer. Okay? Now, having looked at all this material today so far, what I'm going to ask you to do next is to do Video Quiz 17. Now, I have attached Video Quiz 17 to your email, so you can either just look at it on your phone or on your computer. Simply jot down the answers that you feel are correct to Video Quiz 17, and I'll give you a few minutes to do that, and you can then capture it on your phone and send it to me, or what you can do is print the sheet and you can email it to me and scan it, whatever works for you. But you don't have to print the sheet, the actual quiz itself. Just write on it your name, Video Quiz 17, and please put down on there your answers to the 5 questions. I believe there might be an extra credit question on the quiz also, and send those to me, okay? And I will give you a grade for this video quiz. So we're going to end this video now. I'd like you to try the video quiz, and then when we get back together, we are going to start up and take a look at some proofs of the rule of Pythagoras as shown to us by Dr. Mike. Okay, see you in a few minutes.